So in this problem, we are given the value of cosine theta. So that's cosine alpha times cosine beta divided by 1 minus sine alpha times sine beta. We need to show that one of the value of tangent of theta over 2 is given by this particular expression. Let us begin. Now to solve this problem, we're going to use an identity. We know that if we have tangent squared of a over 2, that's given by 1 minus cosine of theta a divided by 1 plus cosine of angle a. So in place of a, we are going to use the value theta. So we know that tangent squared of theta over 2, that will become equals to 1 minus cosine of angle theta divided by 1 plus cosine of theta. Now we will use this particular value of cosine theta. So we get 1 minus cosine alpha times cosine beta divided by 1 minus sine alpha times sine beta. Then in the denominator we have 1 added to cosine alpha times cosine beta divided by 1 minus sine alpha times sine beta. So this will be equals to, in the numerator we have 1 minus sine alpha. All we're doing is multiplying both the numerator and the denominator with 1 minus sine alpha sine beta. So this is going to be one term. This is multiplied to 1, and the next term will be simply cosine alpha times cosine beta. Now we are also going to multiply the denominator with 1 minus sine alpha sine beta. So that gives us 1 minus sine alpha times sine beta. So that's going to be one term, and the next term will be positive cosine alpha times cosine beta. Okay, so let's further simplify. Now what we'll do, we will rewrite the numerator as 1 minus, we'll take negative as the common factor. This gets multiplied to cosine alpha times cosine beta added to sine alpha times sine beta. And in the denominator we have 1 minus, so here let's take positive as the common factor. So we have cosine alpha times cosine beta minus sine alpha times sine beta. The reason why we are writing in this particular fashion, because both these and these are two identities. So here in the numerator we have 1 minus cosine of alpha minus beta, and in the denominator we have 1 plus cosine of alpha plus beta. Fine. Now what we'll do, we'll use the identity. So whenever we have 1 minus cosine of theta, so that becomes equivalent to 2 times sine squared theta over 2. And if we have 1 plus cosine theta, so that becomes equivalent to 2 times cosine squared theta over 2. That means our numerator will be 2 times sine squared theta over 2, but theta is alpha minus beta. So we get alpha minus beta over 2. And the denominator, we have 2 times cosine squared alpha plus beta over 2. So the 2 and 2 gets factored out. So this is the value of tangent squared theta over 2. So we started off with tangent of square theta over 2, and that gave us sine squared alpha minus beta over 2 divided by cosine squared alpha plus beta over 2. Let's do one thing. Let's take the square root on both sides, and we're only going to consider the positive value. That's such that we get tangent of theta over 2 equals to sine alpha minus beta divided by 2 whole divided by cosine of alpha plus beta divided by 2. So here we're only considering the positive value. Now we're going to use the other identity, which is sine of a minus b. We're using this because you can see in the numerator we have sine of alpha minus beta over 2, which can be also expressed as alpha over 2 minus beta over 2. Now sine a minus beta, that's sine a cosine b minus cosine a sine b. And the other value, cosine of a plus b. So here a will be alpha over 2 and b will be beta over 2. That's given by cosine of a times cosine of b minus sine of a times sine of b. Let's use these two identities. So tangent of theta over 2, so that will become equals to we have sine of A. So A will correspond to alpha over 2. Multiplied to cosine of B. B is going to correspond to beta over 2. Minus cosine of angle alpha over 2 times sine of angle beta over 2. Whole thing will be divided by, we have cosine of angle alpha over 2 times cosine of angle beta over 2 minus sine alpha over 2 times sine beta over 2. Now what we'll do, we will be dividing both numerator as well as the denominator with cosine alpha over 2 times cosine beta over 2. We'll do that to the denominator as well, with cosine alpha over 2 times cosine beta over 2, such that we now get so sine alpha over 2 times cosine beta over 2 when we divide it by cosine alpha over 2 times cosine beta over 2. So the cosine beta over 2 gets factored out. We are left with sine alpha over 2 over cosine alpha over 2. That's going to give us tangent of alpha over 2. Then the next term here, cosine alpha over 2 will get factored out. So we'll be left with sine beta over 2 divided by cosine beta over 2, which is going to give us tangent of beta over 2. Whole divided by, now cosine alpha over 2 times cosine beta over 2 divided by cosine alpha over 2 times beta over 2. That will be simply 1. Minus, now the second term will become tangent of alpha over 2 times tangent of beta over 2. So this is going to be the expression for tangent of theta over 2, and this is exactly what we needed to prove. So let's verify. So we have tangent of alpha over 2 minus tangent of beta over 2 divided by 1 minus the product tangent of alpha over 2 times tangent of beta over 2. Yeah, so we've successfully proved that one of the value of tangent theta 2 is given by this particular expression.